Well, hello, friends and foe. Yes, foe singular. There's only one of you. You know who you are. You know. There's very little question about who my foe is. Okay, so, yes, I'm starting late. That's because I had a slightly unexpected hiccup. I got here and I was pretty much ready to go. Hang on. Before I get into that, I need to open a couple of things. Okay, because I was all thrown. All right, before I tell you the story of that little story of woe, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Yeah, so I was here. Also, I just need to get TTS up. Cast mode, here we go. Make sure TTS is running. Stephen, you are correct. It is Peter. My foe is Peter. Hello, Austin. Yeah, so what happened was I thought I was ready. I was here. And then I looked at the camera, the one that is right in front of me, the one that you were staring out of, and there was no lens on it. Because I took the lens off that particular camera to stick it on this camera to take it away because I was trying to get a photo of a sunset. Yes, I know, that sounds so corny. Hang on, Crispian's Moo would not work because I'm still logging into CastNote. Here we go, getting in. Yeah, I have a collection of lenses. So these use micro four thirds lenses. I've got a few different ones. The one that I like as just my general everyday carry it around type lens is the 1442 zoom, which is the one that is on that camera right there. And the reason I have it on that camera is that the zoom, it's not a really wide range zoom. I've got a 4200 zoom or something on the overhead camera. I've got 28mm lens, a couple of those, a couple of other lenses. I can't even remember what. I may even have another 1442. But the 1442 on the micro four thirds, which use, because of the way the optics work in a micro four thirds sensor system, when you talk about how many millimeters the lens is, so the focal distance of the lens, it's different to a regular sensor. So it's not the same as a 1442 zoom on a regular sensor. Yeah, so you can't do a direct comparison. But what am I doing? What am I doing? Chasing random squirrels. End result is that particular lens is ideal for just walking around taking photos sort of things. It covers the sweet spot range where you can do everything from reasonably wide shots for like scenes, looking, just general stuff. You can zoom to some extent, so you can pull in tighter on things if you want to get a good frame on it. Yeah, it's like the good go-to lens that covers the classic Pareto's principle 80% of situations. And I grabbed it off the camera to take it somewhere else, sat down to do the live stream. The lens was on this camera.
I just can't seem to get my moves out.
Can't seem to get your moves out. Okay, I just turned up the volume on the TTS. So now, let's try this one again. Here we go. Play.
I just can't seem to get my moves out.
There we go. Yeah, so the end result was that, and this camera was in a bag that was in my car, in the boot. So I had to go and get that and swap lenses and stuff. And so now, not only am I starting late because I had to get the lens out of the car, I'm now starting even later because I've told you the story about how that happened. American accent, yeah, that is whatever the default, I'm not even sure if that's customizable. The TTS is being generated as an audio on the server side, like as an audio file, and then it just gets played in the browser. And I don't know if I have any control over what voice is selected. Oh, hang on, you have control, don't you? Oh, I can't remember. I don't know. I don't know. Okay, so good morning to Crispian, Sharky, Immy. Come on, catch up. My hot Swedish friend Johnny Bergdahl, Russell Rainey, Any Mules, Paul Schultz. Good morning, Paul. Stephen 447 something. I clicked on it before I saw the name. Austin's Creations, Paul de Grey. Welcome. Yeah, so I just realized that something is going to annoy me greatly, and that is that my trackpad batteries have gone flat again. There's only 5 of us here. Yes, Crispian, that's right. Only 5. Does it? I think a 20-cent coin is too thick for this from memory. Yeah, you need a 10-cent coin or smaller, or a screwdriver. And I intend to be doing some fusion stuff today, which means I very much need the trackpad to be working, because I need that for pan and zoom.
Hello.
Hello. Oh, Henrik. Hello, Henrik. Which means I need... And these trackpads go through batteries so fast, they rip through them. I bought this, how many wasn't it? 10-pack of Duracells only a few weeks ago. Not that long. It goes through 2 at a time. So this is the 5th set of batteries in this trackpad in the last few weeks. Yeah. Maybe that is a sign that I have been at my computer too much over that period, which I would believe. I have been spending way too much time. One of the indicators for it is... Grant says, apologies, Stephen and I are at a radio club event. Ah, cool. Fun. If you're at a radio club event, does that mean that you're out in somewhere a ways off in the boonies, away from any background radio noise? Quite possibly. Those sorts of events are usually held out of major metro areas. Could you measure what the current on the trackpad? Maybe there is a broken IC that uses way too much power.
Could you measure what the current on the trackpad? MB, there is a broken IC that uses way much power.
Maybe. I have a microcurrent because the amount of power that this would draw is tiny. It's just that it's drawing it over a period of time. So I think this is my fundamental problem. I am using my computer too much. And that's right, so this is what I was just starting to say. Hang on, hang on. I need to do something, and I'm going to mute myself. Okay. One of the indicators is that my right shoulder gets really sore. And the reason is that even though I have not used a mouse for 25 years, I think. Yeah, it would have been around 2000, 2001 that I stopped using a mouse. Or was it later than that? No, I think it might have been later than that. I made the switch to the Dvorak keyboard around 2001. Mouse, getting rid of the mouse entirely was a couple of years after that, I think. And so I've been using a trackball ever since. So a trackball combination with a trackpad. And the issue that I find is if I am spending a lot of time on my computer using the trackball, which is, so obviously I use the trackball versus the trackpad in different situations. If I'm using the trackball, I mean, the way my camera is set up right now, it's not dead square on. I'm not sitting dead square, so it's a little bit hard to tell, like if one shoulder is higher than the other. But what happens is, so it actually looks like this shoulder is a little bit lower. It's not. Like I'm sitting pretty much square on right now. But if I put my hand up on the, this is going to be interesting. I haven't looked at this before in the camera. If I put my hand up on the trackball, see my shoulder rises. So that is with it sitting on the trackball. That's with it on the keyboard. Trackball, keyboard. Which is not a dramatic difference. But if I'm doing a lot of CAD in particular, then I'm using the trackball a lot more than the keyboard. Like coding is a lot with the keyboard, trackball is a lot with the when I'm doing CAD. And over the last few weeks I've been doing a lot of CAD. So yeah, laying out boards and things. So what I find is that if I've had an extended period where I've been using the trackball too much, I get pain all through my shoulder, up here into the back of my neck, basically across the traps, and like under here, and yeah, so it's a sign that I need to get off my computer and start doing physical, practical things. And a lot of the time that's quite practical. I can mix up the kind of work that I'm doing. So I end up spending a few hours on the computer, a few hours building stuff, like a few hours at the workbench, just generally moving around and doing things, not so much in a static position. But over time, I can end up, yeah, if I end up with a situation where I've spent, you know, I might have spent 10 hours, 12 hours in one day physically sitting at my computer and doing stuff, then yeah, it adds up. And sadly, that sort of period of time is not that unusual. Although it is better these days. I'm doing it a lot less than I have in the past. My days are shorter these days, which is good. Okay, so other people who have turned up. Already said hello to Henrik. Oh, Mark Laguda is here. Good morning, Mark. Stephen George and Grant Maisels, who are at the radio event. Now, the point... Oh, I didn't turn on my trackpad. I put batteries in it, didn't turn it on. There we go. Is it working? Pair. Yes, it is working. Yay. Okay, launching Fusion. Oh yeah, Crispian said, well, firstly, commiserations for no caffeine available here. Okay, just backing up.
Real lithium batteries in there. They should last longer.
Real lithium batteries in there. Yeah, possibly. So just backing up in chat because I was not paying attention. Okay. At the EMDRC Amateur Radio Car Boot Sale. EMDRC? Eastern... Is that the correct order? Because it's the Eastern Mountain District... Oh yeah, that would be Eastern Mountain District Radio Club. I think that's what EMDRC is. For some reason, in my head, it is EMRDC. But that doesn't make any sense. Yeah, EMDRC. Eastern Mountain District Radio Club. Car boot sale. Cool. Buy something cool. Or sell something cool. Henrik's, this is Henrik's questions again about this. I thought it was milliamps. Well, not when it goes into sleep mode. These sorts of devices, any device like a keyboard that has 2 AA batteries in it, or a mouse that lasts for a year on a AA battery, they go into incredibly low power modes, and they're only woken up in certain situations. So to make the batteries last, what they do is a whole bunch of tricks that that put it into the picoamps region, essentially below the chemical degradation rate of the battery itself, because batteries have a shelf life. If you just take a brand new battery and you stick it on your shelf for 10 years, come back and measure it, it'll have lost power. So, and that's just because of the chemical degradation that occurs within them. So they have a very slow internal self-discharge rate. And the standby power on devices like, another good example is Zigbee sensors, like those little Xiaomi sensors. Some of you will have seen Dylan from the Stockpot did a video, a really clever video. Okay, I'm going to shout this out. Dylan did a cool thing here. Sorry, I'm just checking. Let's see. Where is Dylan's video? The Stockpot. Here we go. I will find his channel. This one, I'm going to play and then stop it because I don't want to. Here we go. This full sized, and here. So, yeah, you can't really see a whole lot from there. But if you if you look on the left, this is a standard commanded adhesive hook, like you would find in a typical bathroom or kitchen or wherever. And you hook a towel on it and it stays there. You hope. It doesn't fall off the wall. You hope. And then on the right, see this one? It looks a little bit different. This is Dylan's 3D printed version. I'm going to hit mute on this because I want to play it without getting a copyright strike. And I'm just going to show you little clips of this. This is clever. Now, I'm not sure if Dylan came up with this idea himself or if he saw it was inspired by something else. But this is one of those few times that I have seen a project and gone, wow, that is creative. Like, it's not just a variation on something that other people have done. It is an actual new thing that I have never heard of before in home automation. And it is a sensing hook. So let's drag this back. Is this going to... Yeah, I'm going to hit play on it. And what you will see is the hook is in this upper position. See there's a little gap just below it there. Excuse me. And when I hit play, you'll see that the towel is going to move the hook down. Joink, there it goes. And that is, what's inside here is a door sensor. I'll just jump along a little bit. In fact, I'll jump. Yeah, this video is worth seeing. Dylan's done a really good job with this. Here we go. So I'm going to find a bit where it's showing the internals. Somewhere like that. So what you can see here is this is the 3D printed body. And then what he's done is disassembled one of the reed switch magnetic door sensors, door/window sensors, that have a coin cell in them, and they are Zigbee. So what they do is they're in a quiescent state most of the time. Oh! Wow! Tassie! Thank you, Tassie. I took a swig of coffee just for you. That's very generous. Yeah, so Tassie, go and smack Pete upside the head. Find out why he's not here. So, yeah, these things. So what got me onto talking about this was Henry talking about power usage in trackpads. So this sensor, and I've got a bunch of these around the lab as well. So I've got these on different doors around the place. The way they work is they've got, in fact, there's a, I think there are frames in this video that explain it as well. In fact, yes, there definitely are frames in this video that explain it. Somewhere, back here, back near the start, I think, when Dylan is talking about it. So he talks about the problem. But, okay, the upshot. Henrik! Behind the scenes. Thank you, Henrik. So Henrik said, a rainbow clapperboard with the words, behind the scenes. Okay. So yeah, here you can see this big one on the left. This is the enclosure with the sensor in it. So there is a reed switch, which is a magnetic switch, the microcontroller, which connects to Zigbee, and the battery, little coin cell like a CR2032 or something. I can't remember what size these ones used. And this little thing on the right, it's nothing but a magnet. It's just a magnet in a plastic enclosure. So when you bring the magnet near the sensor, it closes the reed switch, and when you take it away, it opens the reed switch. Same as like an old school security sensor, and which is also what these are used for. You stick them on windows and things, so if the window is opened, then it gets triggered. So what Dylan has done is found a very creative repurposing of this sensor. Somewhere in here. Action shot. Here we go. Where are we? I want to find that again. CAD action shot. Dylan in action in Fusion designing the enclosure. So what he did was he pulled apart. Oh, here we go. So this is his diagram of the reed switch in use. Bring the magnet near it, closes the little reeds, and then you get power going through, and then you pull the, and there's hysteresis in this, which is what he's talking about here. So pull it away, and then at 9mm, or whatever the number happens to be, the reed's open, and the circuit is opened, and it can detect that. So what he did was put that inside a 3D printed hook. There we go. So, in fact, if I so there it goes, opens and closes. So if you put something on the hook, I'm just going to pause at this point up here. Yeah, so pushes up and down. And as the hook moves up and down, it's spring-loaded, so it tries to return to the upright position. As you put something on it, like you hang a towel on the hook, it moves the hook down, which then triggers the sensor, which then sends an update. It broadcasts over, well, it's not technically a broadcast. It is a message to its paired Zigbee coordinator. The Zigbee coordinator can then communicate with other devices on your network. So it could be, I'm pretty sure Dylan uses Home Assistant. So in this case, it's Home Assistant, which then does something. Yeah, so the basic premise of this video is to complain if he has a shower and then doesn't put the towel back on the hook. That's it. That's the whole thing here. But so that he doesn't leave it lying on the bed or something and cause problems. So the result is you put the towel on there. This thing sends a sensor, and then he's got some logic. Where is the logic? It's explained in here somewhere. Sends notifications. I can't remember where. Somewhere in here, he was talking about the specific logic of. Oh, this might be it. Towel hook. Yeah, specific logic of if it's after a certain time, like within a certain time window, and the towel has been removed, and then the towel has not been put back within a certain time window, then send a reminder. So it's kind of the actual application is it's a little bit frivolous and trivial, but then he talks about some other applications like where is it? Yeah, not this one. This next one I think was about kids' school bags. So so if you put a kid's school bag on there, and that could do something like allow them to have internet access if they come home from school and they put their bag on the hook, that sort of thing. The whole point here is that it is knowing whether something is hung up then allows other action to be taken. And where are we? Oh, yeah, there was this one. This one was, and to some extent, a lot of these are a reach. Like it's almost trying to find a problem for this thing to solve. It's a solution, and it's just making up problems for it. This one is having your bathrobe hanging on a hook, and if you get up during the night, so it has to be within a certain time window, and you take the bathrobe off your hook, then have it turn on lights through your house as like a path to the bathroom. So if you wanted to get up during the night, go to the toilet, then you grab your bathrobe and your path is then illuminated to the toilet, and you come back, you put your bathrobe back on the hook, all the lights turn off again. So yeah, I think once people start messing around with this idea, and then he was just talking about other things. So I think once people start messing around with this idea of sensors in hangers, yeah, there can be interesting things that come out of it. There are I've seen other types, other approaches to this in the past. I saw one some years ago with a car key hanger, and the way this one worked was that it was using, I think it was 3.5 millimeter plugs, basically like the small style headphone plugs. And so there was a board with a whole lot of sockets in it, and you'd have a headphone plug attached like a little dongle onto your key ring, and you'd plug it in, and your keys would then be hanging from the board. And you take the keys off, and the system knows whether the plug is in or out. So if, for example, you come home and you don't put your keys there, yeah. Anyway, notifications. The whole idea being that your automation system can keep track of the state of different things. And a smart hook as a device that knows whether something is hanging on it or not, I just thought that was a bit of a left field idea. Never crossed my mind to try to make a hook that knows whether something is hanging on it. I thought it was clever. So, I am going to, in the spirit of cross promotion, I'm going to drop outside the box said there's something humorous about having a hook interrupting internet services. Yeah, it's like old style phones where you hang up the phone, you put it back on the hook, and it hangs up the line. Okay, I am going to drop the link to Dylan's video in the chat. So if anybody wants to go and check that out, please do. And how long is the video? 7 minutes, 43 seconds. So I am now going to stop for 7 minutes and 43 seconds and wait for you all to come back. Here we go, start the timer. Okay, that was a terrible joke, and I'm not even going to try to follow through on it. Okay, back to... Oh, Tassie Bob said... Oh, and Don S from NZ is here. Okay, so, people who have joined the chat, Tassie Bob, who I said hello to earlier. Evil Dees! Haha, welcome, Evil. I have a message to send... Okay, I was going to send you a message, Evil, just before the stream started, and I didn't because things went off the rails with the lens. I will send you a message after the stream. Yes. Things that I will not disclose on stream. Welcome to Don S, Simon CBR, and me. I appeared in the chat because I sent that message. I am in my own chat. Yeah, Simon said, sounds like a solution looking for a problem to me. Yes, that's right. Oh, Tassie Bob said Pete might be at work. Yeah, quite likely. Oh, and Tassie Bob says, I can see a toilet seat version of that. Yeah, a reminder. Put the toilet seat down. Yeah. Okay, so going back in time, back in the chat, Crispian said, going through 18 gears all day is likely why I have a frozen shoulder the last 3 years. Yeah. I had one and it got pretty bad. I ended up having some physio on it. There is a guy at the gym who is he's a physio who does remedial massage, and this was at a time I had an injury on my left shoulder. I had a rotator cuff injury after being Kimura'd. For those, if you know, you know. So I've been Kimura'd multiple times. This particular thing, I had an existing injury on my shoulder. I got Kimura'd by a training partner, and it went too far. And I ended up in a pretty bad state. This was beginning of last year, it would have been. Yeah, I ended up it became progressive. I ended up having a lot of trouble moving my arm, and I ended up having some rehab sessions. I went along to 2 physios. One physio gave me some general exercises to do. The other physio did a couple of sessions of very deep tissue massage, which was very painful. It was yeah, one of those things where you got to tear down to build up again, but it worked so effectively. Yeah, I gained so much mobility back in my shoulder after that. Because my very vague understanding is that what happens in the process of what's called frozen shoulder is when you have limited mobility, and often you may be holding yourself in a very specific position and not moving, which over time causes muscle fibers and other materials to sort of bond, to stick together. And so it kind of needs to be broken up again to free it up. And so it's kind of ridiculous. He got his hands way down, behind my scapula, in ways that I did not think were physically possible. Going behind the scapula, his whole finger length, that sort of thing. And it hurt so much. But it was one of those things where there was all of this pain, and then afterwards it was like, oh my God, I can move. That feels so good. So I had a couple of sessions of that, and that got me back on the track to recovering. It was, yeah. So, Crispian, I'm not saying that's the solution to you, because everybody is different, all situations are different. That was just, in my personal circumstances with the injury that I had, and it was not a super long-standing injury. It was in the order of a few months. It wasn't 3 years. It was a few months that I could barely move that arm, and then yeah, I couldn't sleep. I couldn't lie on that side. I was not sleeping because even if I lay on my back, it would hurt too much. It was stopping me from working. It was pretty bad, but it wasn't a super long period of time. And getting that physio just, yeah, it made my life so much better. What are we doing today, kids? What are we doing? My plan. It's already 10:30 something. My plan was, okay, I'm just doing something on the screen up here, getting into Superhouse projects. It was Beetlebot. Oh, Crispin said I asked about surgery and they weren't particularly keen. Yeah. Ooh. Well, I hope you do manage to find a solution to it. Tinker said, very important suggestion, have a real doctor look things over before trying physio as a solution. That is true, yes. Have a real doctor look things over. Some issues can be made much worse. Yes. Yes, Tinker, that is a good suggestion. In terms of medical, I know there's this cliche about people not wanting to go, like not wanting to use medical services, and I don't really have that problem so much, certainly not in recent years. I think I used to a fair bit. I would be in pain, I would have some injury, something would happen, and I would just think, it'll get better. Not do anything about it. But I think probably since I started doing jiu-jitsu, somewhere around about that time, so maybe, I don't know, 15 years ago, give or take. Is it that long? I don't know. I'm going to have to look up. Hang on, I can find out. In fact, I'm going to look up the date of my very first ever jiu-jitsu class. And I bet I am off by years and years in terms of when it was. Yeah, I was off by a couple of years. Okay. It was my first ever jiu-jitsu class was 14th of November 2013. And it scared me so much that the next one I went to was 28th of November, so 2 weeks later. I was a mess after that first one. Tambo got us to do 60 push-ups in that first class. Yeah, that would have been as part of the warm-up. Okay, 60 push-ups. So that was, yeah, so 14th of November 2013, my first ever jiu-jitsu class. So probably in that sort of time frame, I've been pretty good about medical intervention. Like my GP and I see each other quite regularly. And also I pay a lot of attention because of the whole Crohn's disease thing. I've had many injuries of different types. So over that time I have had multiple CT scans and many x-rays and many trips to the GP, to the physio. I go to the doctor, like to the dentist every 6 months at least. So yeah, for the most part, I am reasonably on top of going to professionals when required for assistance. So, where are we? I'm just going to cover the preview window for OBS in case that causes any rendering issues. Yeah, okay. There we go. So, where we left it was oh, yeah, and the other thing is, so we were talking about physios, and Tinker suggested, I mean, I think this might be a little bit, how do I put this? A little unfair to physios to say that you should see a real doctor first. That is very unfair to physios, but I get what you're saying, Tinker. The point is, when you say a real doctor, you're probably talking about a GP or a doctor who has someone who is less specialized. Because in resolving an issue, typically you want to look at the overall system so that you have context. If you go to a specialist in a particular area, then to some extent you are bypassing the diagnostic process and you presupposing either a problem or a solution to a problem. So you are thinking, okay, I have an injury in this particular part of my body, therefore I will see the specialist about that particular thing. But it may be that that is only appropriate in the context of some other treatment. So yes, Tinker, I agree with your point that seeing somebody like a physio should be in the context also of general medical advice. And yes, and the other thing is that in Australia, at least, I think there are certain, and it also depends on your insurance. There are certain services that you can get that if you get a referral from a GP, then it ends up being cheaper, or you can get stuff bulk billed or whatever. Stephen says, physiotherapists still need to do whole university courses to be able to call themselves that. Yeah. Yes. Yeah, I am not disparaging physiotherapists at all. It is they do really, really cool, useful things, and they have a lot of knowledge. Crispian says, I've had over 500 x-rays. How many bananas is that the equivalent of eating? How many high altitude flights in an aircraft at 40,000 feet? So, I am struggling to engage my brain this morning. This is the actual reason that I was going to do the stream. Okay, no brags. Come on, throw them at me. I need something to distract me. Woo. Just got to move the space mouse out where it should be. Okay, so where we left this was, I was messing around with top versus bottom wheel positioning, and I pretty much came to the conclusion that I want to put the motors underneath the main PCB. Now, one option here is we use two identical PCBs, and we put one on the bottom, one on the top. We clamp the motors in between them, and yes, so that has, I hadn't talked about this previously. I'm going to back off from that train of thought and come back to it, because it does have some interesting implications. Now, it means the top could be a laser cut plate. Oh, I don't know. I am starting to second guess everything now. I am, possible courses of action that never even crossed my mind previously. All right, so here we go. Before I get into it, I am going to mute and drink. Okay. Now let me recap. Let me explain. There is not time. Let me summarize. The wheel above the base is, in fact, I've got one right here. This is the lollibot thingy majiggy me from John Spencer's project from years ago. The way we're looking at this now, we can see that the motors are on top of the main base carrier. It's got a battery there, it's got the Lolan 32 there, and on the PCB it's got H-bridge motor drivers here and here for driving these two motors, and the little skid under the back, which is an LED. So it slides around on this and drives around. Okay, this is my thought process. Right, going back to here, whoops, back to here for a moment. This, with the wheel that you see on the right here, is equivalent to the lollibot design, where we have a PCB on the bottom, and then we have the, yeah, sorry, my brain is going, I'm thinking of all sorts of things. So then we have the motor sitting on top of the PCB, so that there is a small clearance between the bottom of the PCB and the ground. It also means that the top of the PCB is partly obscured by the motor. There is critical real estate here that is taken up by the motor that could be used for other purposes, so it kind of gets in the way. So this is the lollibot approach. And then the way my brain went was, let's put the motor on the bottom and have the PCB up here, which means that we now end up with a whole lot of clearance. We've got the clearance from the bottom of the PCB here to the ground down here, which means that we can sling a battery underneath, and we've got lots of vertical space to stick a battery underneath the body and leave the top clear. So in this model, we have the motors underneath, we have the battery underneath, and we have a very large clear area here, which can be used for things like the ESP32 and the motor drivers and whatever else needs to go on there. Okay, that was the basic logic. And it also means that in this central area, we have plenty of unobstructed space to put a mounting plate, like a Lego plate, where you can attach a manipulator that would reach over the front of the bot to be able to pick things up or do whatever we need to do. Okay, so when I lay it out like that, I think it seems fairly logical to put the motors under the base. It does have many, many advantages compared to the overslung version like this, which is lollibot style. But now I am thinking of something that is more of a hybrid approach. Don said, is this a fighting bot? No. No, it's not a fighting bot. It is a low-cost robotics platform for allowing people to experiment with machine learning for controlling robots. So doing things like using vision language action models. A lot of people now these days will be familiar with LLMs, large language models, and there are other things. So LLMs is what most people know. But LLMs are only one way of using machine learning, and there are many other things that you can do, such as VLAs. And so the mission that Andy has been on for some years now is the integration of robotics and machine learning. And the plan with this is to make a low-cost platform that people can hook up to their own machine learning pipeline and process video that is coming from the bot and send commands to it so the bot moves around. So yeah, it's basically the idea of taking machine learning or AI and extending it into the physical world. It's a low-cost development platform. Evil D says, don't forget Fusion 360 now has AI integrated with MCP so it can make changes to your model for you. What? What? Evil. I did not know that. I don't even know where to begin with thinking about that. Of course, we could always put one motor under, one motor over so that it runs on an angle like this. So that would be its natural pose when it's sitting on the ground. No, let's not do that. It's the sort of thing I would do just to freak people out. Make a bot that is diagonal, but let's not. Oh, low cost, so not NVIDIA. No. What we are going to do, the whole point of this, so for context, what Andy and I are planning is a series of robots at different price points. We want people to be able to get into this very cheaply and easily and have options at different levels of complexity. And the goal with this one is to make a low-cost mobility platform with a camera on it. And then all of the processing will be done off-board. So what you would do is you would stream video from the camera, which would go to a pipeline. So it could be using a third-party service, like it could be running like a classifier on your laptop, for example, to be able to find objects in the room, and then the output of the classifier goes to the next stage of the pipeline, which then decides what to do. Like, do we want to move towards that object because we have detected that is the thing we want to get up close to, and then it sends the commands back to this. So the idea with this is that fundamentally it's just a very basic little mobility platform with a camera on it. There's nothing super special about it. The fun bit will be integrating this into the machine learning. Austin says, did you see the file I had sent you? I don't know. Oh yeah, TTS being dumb again. Where is... oh, blocked by bad word detected. I wish I could overcome this. What happens if I click that?
Be interesting to compare center of gravity and its effect.
Ah, okay. That was Tinker. Yeah, there was something weird about it. So I manually triggered the TTS that time. And I noticed that Austin... was it Austin who said something? Yeah, Austin. Why did it not say that? It doesn't even appear. It doesn't even appear in the chat list. Anyway, I don't know what's going on. Okay. Back to the actual chat. Okay, so... Oh, Gav said, you're going from an F1 car to a monster truck. Cool. Yeah, kind of. Austin, no, I did not see the file that you had sent, I think. Unless you sent it. Is it something that was sent in Discord? I'm just going to open Discord and check my DMs. See if I've got anything from you. Austin. Ah, there you go. Oh, that one. Seeing the latest live stream preview. Oh, yeah. I hadn't actually opened Arduino RC car modified setup. Okay, yeah, I hadn't even opened Discord since then. No preview available. Download. Oh, it's a step file. Okay. Let's try doing this. I'm going to do that just in case. Select files, because I don't know what is in, where is it? My downloads. My downloads. View as list. Sort by date added. There we go. Uploading, upload, and back to here. Let's see what it is that Austin has sent. Arduino RC car modified. Where are we? Where are we? Donna said that I should listen to the Lex Friedman podcast interview with the Australian inventor of OpenClaw, now partnered with OpenAI. Okay, I shall. I haven't seen any Lex Friedman stuff for a little while. Crispian says, now I have a new AMD video card. My My PC has been stable for months. I'm just going to open that while I'm reading the chat. And I can do things with it. Well, that's good. Having a computer that you can use is far better than a computer that you can't use. Cool. Okay, so this uses 4 of those motors. It's like a little car. Cool. And it looks like that's a 3D printed base, is my guess, just based on the fact that it's got these little studs and things coming out of it. There is a servo for steering, for twisting those front wheels around. So you can see there's a steering mechanism in here. Steering mechanism goes across to the servo horn. And yeah, cool. Down there, that looks like a voltage regulator module. That's my guess. That's like a little buck regulator. There is an H-bridge in the front with a big heatsink on it. And there's a, is it like a Lolan or something, or a some related ESP32 base board, and whatever that big red thing is, possibly a battery. Is it a battery sitting in it? Am I making you all seasick now because I'm spinning this around so much? Possibly. Yeah, cool. That's nice. Is this your work, Austin? 2 motors, entirely 3D printed, 8.4 volt battery. Yeah. Yes. Zed Parky said, hello, that looks really innovative, even if it is basic as you said. Sorry to ask, but have you shared any info about ESCs or BECs? ESCs are electronic speed controllers and BECs are battery eliminator circuits. Not really. I have not. Somewhere around here I have, yeah, there is a whole, there, not that, this. How drone ESCs work.
This drone accelerates.
I'm going to stop that one. That video is related to this. Open 4-in-1 AM32 ESC. So anyway, I'm not going to get too sidetracked into ESCs right now, but that is something that I brought up. I think I might have shown that last week. So, no, what I'm going to be doing, the plan for this is to make a basic skid steer system. Now, this is very clever and very cool, and I approve. It gets the big stamp of approval. Nice one, Austin. But it is a car. I think that making this would end up being just a little bit more expensive than making this. Maybe I'm wrong. I don't know. But the goal with this is to be as simple as possible. So basic, instead of having throttle and steering, We have a basic skid steer system, 2 motors only, 2 H bridges, and an idler on the back, like a little bogey thing that slides along on the floor. Austin says, indeed my work, but remixed from a design on GrabCAD to be easier to assemble. Nice. Yeah, that is cool. I am so tempted to just send stuff to, where is it, that one? Yeah, like that. If I isolate that one, where is it? There, isolate. If I isolate that, yeah. It is very tempting to just send this to the printer and start messing around with it. But I'm trying not to. I am trying not to distract myself too much right now. Yeah. Maybe a future version can be like a 4-wheel thing. So now this is where my thought processes are going. There is an alternative here. So we can have lollybot style top slung motors, or we can have bottom slung motors. Or what we could do is have the PCB on the bottom. So have it bottom slung like this, the motor on the top, PCB on the bottom, and then what I could do is laser cut another piece that is the same dimensions, so follow the same outline, and that would go above the motors. So the whole thing would be a sandwich. There'd be 2 layers with the motors in between, and in that gap, what we could do is have maybe a slot in the back where a battery slides in, and that would put the weight towards the back, which I think is going to be important when it comes to reaching over the front with a manipulator of some kind and picking stuff up from the front, because that's going to throw a lot of mass forward of the wheels, which is the balance point. So if there's too much weight to the front, instead of running along with its little back skate on the ground, it'll go joink and it will just face plant if it tries to pick something up. So we need mass at the back. It's like a forklift. You need weights on the back to counteract the fact that you've got your load in front of the front wheels. Paul says squirrel count 10. So is that binary, octal, decimal, or hex? Yeah. Perhaps 2 motors with a PCB slung between them, says Vic. Vic, what are you doing here? I thought you were going to like a family event. 0x0A 0001000. Hang on. Why are there only 7 bits in your binary representation, Paul? So what? Yeah. Oh, okay, so my brain is going in all sorts of directions at the same time. It's like being pulled in different directions because I am thinking through all of the design constraints here. One of the considerations is, who is going to be making this? If it is going to be me that is making it, it is not a problem to mix multiple techniques, such as a PCB fabricated for the main structure, a laser cut plate for the top, 3D printed brackets that go in between. So, this is the thing. A lot of people have access to one of those technologies, but not all of them. People may have access to a 3D printer, but not a laser cutter. They may have a laser cutter, but not a 3D printer. They may not be able to do PCB fabrication. And so for me personally, the way I would approach this, if it was just me putting these together, is to optimize for the minimum, is optimize each part of it for the construction technique that is going to be best for that part. So I would use PCB for this. I would use a laser cut plate for the top section. I would then put 3D printed brackets in between to do things like hold the motors in place, to hold the battery in place, a mounting bracket on the front, so to go on here. There is going to be an ESP32 cam mounted on the front. So I would make a 3D printed bracket that goes on there that the ESP32 cam can attach to. And that's not a problem. I could 3D print a bunch of parts. I can laser cut a bunch of parts. I can fabricate PCBs. But is that going to rule out other people who want to replicate this work? And that is a serious consideration, because the point of this, I'm just going to have this so that it's, there we go. It is now sitting on my head, almost. It's like long travel suspension compensating for the fact that it's up on a box. Is it... Tinker says, make all the parts on a manual mill, including the PCB. Vic says, making Monty Python references. Yeah. Perhaps two motors with a PCB slung between them. I am acting as a large speed bump. So Crispian said, 3D printed motor holders with little slack in the vertical plane to allow articulation and include a small spring equals suspension. Yeah, I think this is overcomplicating it though. Now, there are many things like that that could be done for optimizing this, but essentially this is a tripod. One of the benefits of doing a skid steer system is that you have the two drive wheels and then you have an idler. That forms a tripod, which means that you're going to have 3 points of contact at all times, regardless of the surface. So if it's running off the edge of a rug or something on a wooden floor, and there's a difference in height of 8 or 10 millimeters, doesn't really matter. It's still going to be sitting with all 3 points of contact. So for a very simple skid steer system like this, I would not bother with suspension. It's a cool idea, and it's interesting in terms of demonstrating suspension, but I don't think it would be worth the trade-off of the complexity of doing it for this very simple application. So what I'm visualizing here, I should start actually doing stuff in CAD rather than just talking about it. Crispian says, it looks like the LED might dig into carpet or floor gaps and get stuck. Yeah, that, and even on, yes, definitely on carpet. That is an issue with the Lollibot. It's got this 8mm LED, so it's an 8mm diameter, which means it's only a 4mm radius on the curve on the back. And this slides along nicely on things like a hardwood floor. It goes pretty well on industrial carpet. You know, the very low nap carpet that's used typically in high traffic areas like convention centers and those sorts of things. But as soon as you have carpet that has more texture to it, this sort of catches on it. So there needs to be a better solution for the idler at the back. And there are a few ways that can be done. It can be done, there was another bot that I showed a couple of weeks ago that had a very large ball bearing, it's probably like a 12mm ball bearing, captive in a little plastic clip. So the bottom of the ball bearing was exposed. There are things like that that can be done. You could use something like a marble if you wanted to get a large, fairly large sphere, or even something like a table tennis ball, which is physically very large. If you got a table tennis ball and cut it in half, that gives you a pretty decent sort of smooth rounded surface that you could attach to the bottom of it, and then that would be able to slide on most surfaces. It would abrade if you ran it on concrete, for example. You'd abrade through the ball because table tennis balls aren't that strong. But on carpet or a lot of other surfaces, I think that would work really well. Vic says, I did one of these once. You can extrude SVGs for printing, or laser cut them, or CNC them. M3 screws provided the vertical bits, and rather than print bracketry, we just use zip ties. Yeah, cool. Okay. Skid steer with tracks, 2 points of contact. And Crispian said even more like a mouse, but using the ball as a weight. Yeah. Hang on, I'm going to open hardwareconf.org. Ah, yes, come on. I know, there's no SSL certificate. Bite me. Yeah, so this is the Lollybot, which is the one I've just been waving around at you. Now, where was the SimpleBot? SimpleBot. Are there pictures of this? Yeah, there should be. This one. So this one was done out of core flute and cable ties. So when did we do this one? SimpleBot 2015. Yeah. Oh, what's that one? Bearings. Tinker is sending me. Yeah, this sort of thing. Oh, that's expensive though. But that's the concept. This sort of thing. Unit mounted surface bearing. Yeah, so it's a ball bearing, like a round bearing, inside an enclosure. And typically these things are used in the orientation that you can see here. So they might be fixed onto a surface, and if you have a few of them, it forms a surface that you can move objects around on in any direction. Like a conveyor belt, but conveyor belts typically are linear. They have a moving surface. With this, it's a surface that you can move things on with very low friction. And of course, you turn it up the other way, and now you have something that you can slide around on a surface with fairly low friction. So this is the sort of thing that would sit under the back of the bot. Yep. Cool. Thanks, Tinker. That is a good way of representing it. Those used in freight aircraft, says Crispian. Yeah. Oh, hang on. I need a coffee. A cough. I need to cough, and I'll take a swig of coffee as well. Okay. Tinker says, have worked at a table with about 1,000 of those on it. That would be fun. It'd be like, a bit like an air hockey table. You put things down on it, you push them, and then they just keep moving. Very low friction surface. Vic says, have to scoot shortly. Family roast is starting to set off fire alarms. Yeah, don't burn the house down, Vic. And have a fun event too. I'm surprised that you are here. You should be having fun with family. So this is the super low cost thing. But yes, Vic is correct in that. Oh, hang on, I just saw something else. ES Plant. Yes, this is a project that I want to get back to. Where is the? Check out these the talks. Josh was talking about, this was in the very early days. Yeah, and Alistair talking about Linux CNC. This Peter Hardy talking about the Kerbal Space Program simulator. Yeah, that was awesome. Anyway, this will be, yeah. Yes, planned. Yeah, this was the the watering system controller. Anyway, what are we doing? What are we doing? Okay, so this. I want to actually do something, not just be talking about doing stuff. But I'm still in this paralysis thing of considering all of the options. What Vic said, though, is valid. If I think there should be at least one plate which is a PCB. So there are a few different design approaches we can take to this. We could make it so that the control system is built up out of modules in the same way that the SimpleBot was, which is that one I just had on screen, where the structure is made out of core flute in that case, and then there was a Raspberry Pi and other stuff that was attached to the core flute, but there was nothing special about the Pi or any of the other electronics. It was just off-the-shelf modules attached with M3 bolts and cable ties and things. Or we can do a custom PCB and incorporate all of the electronics onto that. Now that was my plan, and still is my plan, for BeetleBot. Then for additional mechanical structure, it could be, if for example there is a top plate that goes onto this, and it is just a flat plate that is designed for laser cutting, if someone doesn't have a laser cutter, but they do have access to a 3D printer, they can just 3D print it. You get almost the same end result. It takes a lot longer because 3D printing takes longer than laser cutting. But if that's what you have, then that's what you can do. So I think Vic is right that designing this with the intention of using a PCB plus 3D printing plus laser cutting does not necessarily rule out people who want to make it without access to a laser cutter. It possibly rules out access to people who want it without access to a 3D printer, but I think that barrier is far lower these days than it has been in the past. It is very, very common now for people to have access to 3D printers. And Stephen says, or can you ship the laser cut parts with the kit? Oh yeah, absolutely. For me making them and distributing them, I can provide them with all the parts. That would be the plan. That's not an issue at all. I can make kits. I can supply them all with everything you need, including 3D printed parts, laser cut parts, etc. The issue is someone coming across this design who is totally unrelated to me, and they want to reproduce it and they don't have access to all of the tools and things that I do. Because something I've got to keep in mind is that I can reach for just about any tool I can imagine. Anything I want to fabricate, I can do it. But that's not necessarily the case for other people. So I need to restrict the requirements on reproducing this project. Nguyen says, I liked your stream. Well, thank you. Tinker says, I have neither laser cutter nor 3D printer, do have a little tabletop mill. Okay. So you could, yes, you could machine a plate for a top plate. Zed Parksy said, about cutting, I'm currently mentoring some dude's 10th grade building battle bot in my garage. 3mm steel, 25 kilogram weight limit. I've been cutting like 40 minutes with the grinder. Yeah. Oh, Vic's suggestion was, to tinker was, print out the SVG, stick it to your flat material, and mill away. Yep. And Tinker says, yes, exactly. Yeah, yeah. So it's like a paint by numbers sort of thing. I am... all right. Okay, so talking this through, the more I think about it, the less inclined I am to limit myself in the technologies that are used or the fabrication techniques that are used. And I think I could just use them all. So here is my new idea. Now, I moved this. I kind of want to move it back, and I don't have history. I don't have the movement history here in this assembly. Now, which one is it? Not that one, that one. Okay, let's try to get this approximately. Now, did I just do it like, surely I didn't just do it like that. Maybe I did. I should realign that axis. Bring it down to about there. I'm not actually caring that much about being super precise at the moment. There, and then I think I need to bring it... Did I need to bring it back a little bit? I don't know. No, now it's behind the other one. It is distantly behind the other one. Maybe that one was up like 1 millimeter. Yeah. Bring it up 1, which brings it up just slightly clear of the base. Yeah, it's something like that. Close enough. Okay. This is just my mess around visualization sort of assembly because I want to see what is going on. Okay, so now I want to duplicate this. Let's move that. No, I want to copy that. No, I don't want to copy the body. I want to duplicate the component. And I'm going to move it. Oh, it's still a PCB with all the associated parts. Well, that's rubbish. What I need to do is project and project onto a new... Can I do that? Oh, that. I want to project onto a new sketch and then create a new body. But this will do for now for visualization purposes. All right, so this is kind of where I am heading towards. So what I would do is have the bottom plate as a PCB. That PCB would have the electronics on it. So it's going to have the microcontroller, the H-bridge motor drivers for these two. It'll have a connection for the battery. So that all of the active electronics, it's all active, will be on this, which is the PCB. Then this piece up above it, this could be either laser cut or 3D printed, doesn't matter, as a plate. Those two will be attached by standoffs or 3D printed brackets. I think the way I would want to do this is to make 3D printed brackets that go in here so that the motor's attached to those brackets. These motors have these holes through them like this, so they can be screwed into the brackets, and then the top and bottom plates screw into the brackets as well. So that gives it the structure. Then what we would do is have a 3D printed bracket that goes in the front here between these two. So it'll go between that face and that face, and it will give a flat panel on the front here. So we have a bracket here on the front, And onto that, we attach the ESP32 cam. And that gives it the forward-looking camera that is required for the vision for the system. And in fact, what we could do is we could recess it. So we could take that curve that is here, and then we could cut into this so that the 3D printed bracket fits in there, and then the PCB ends up fairly flush. So instead of the ESP32 cam hanging off the front here, like a hood ornament or like a bowsprit on a sailing ship, we have it recessed slightly into the body here so that the front of the camera module is pretty much flush with the front of the bot. Then what we do is on the back here, we make a little 3D printed assembly that's a U shape. And that forms a socket, like a pocket rather, into the back of the bot that you can slide batteries into. So the back part here would have the battery slot, and there could be something as simple as rubber bands across the back of the slot to stop the battery falling out, or Velcro or something. If it's rechargeable and there is something like a USB-C connector on here to plug the whole thing in to recharge it, then the battery may never even need to be removed. It could stay in the bot and yeah, just be clipped into place. Oh, and battery from the link I sent last week hanging on the bottom. Yes. Yeah, the battery. Yeah, the battery in this cavity. Now, what is from... no. Don't want that. I want from that face to that face is 23 millimeters. There's a little bit of a gap there. What is the dimension on... Oh, I've got this right here. I have calipers right here. So, what I'm talking about here is essentially replicating this structure, but adding another plate on top. And the thickness of these motors is 22 and a bit millimeters, almost 23 millimeters. If we say 23, that allows for just a little bit of space. So 23 millimeters in between the two plates, which means we would have space for a battery to slide in the back. So imagine we've got this. In fact, I can mock this up. Where did I put SimpleBot Pi, TankBot? I've got all the other bot boxes down there. Where is the box for those? Up there, maybe? TankBot, PiBot, SimpleBot. Come on, I don't have enough robot boxes around here. I don't know where they went. Anyway, what I was going to do was just grab another PCB from this and stick it on top to show you the sort of structure that is in my head right now, that is starting to coalesce as the plan, as much as there is a plan. Is it under here? There have got to be more robot boxes around the place. Up there, maybe? It's probably in... no, not there. I don't know. Those are conference badges. Somewhere, I have the Lollybot box, which had a whole lot of PCBs and various other things in it. Come on. Nope, I don't know. Doesn't matter that much. He needs a robot to manage his robot boxes. I do. I very definitely do need a robot to manage my robot boxes. Too many robot boxes, or not enough robot boxes. Either way, it's a problem. Okay. So, one thing I have not done. Okay, I'm going to do this because I want to do something that is actually useful on this stream. I did this design, oops, this shape of the PCB that you see here. This was done, that one, which one do I want open? Where is the origin of the actual shape? This was done entirely from memory. I did not have this in my hands at the time that I did this. So when we were doing it on the stream that day, I just freeformed this. Like I just took a punt and drew some curves, and it kind of came out like this, which kind of looks like this approximately. But it was very approximate. And I do like the proportions of this. This one turned out very, very nicely, and I do want to get it close. So what I'm going to do now is just sanity check dimensions, because we've been looking at this in CAD, not in the physical world, and I want to know how far off it is. For example, what is the distance? Can I measure between, what points do I want to measure between? Well, what's our scale here? That is, so we've got a central mark there. Let's do a construction line. Oi, what? Measure? No, I don't want to measure. I want to do line construction from there. Oi, why did it not go to construction? All right, line construction. There we go. Come on, Fusion, get with the program. All right, and then I'm going to make that one. Can I do it off that? No, I can't. Can I make that coincide? What constraint can I apply? Coincident with that? No, there's no point for me to attach it to. All right, I'm just going to be crude, drag it to there. This is just a bit of an estimate. There's got to be a good way of getting a measurement off that. So that to there is 66 millimeters. All right, that I believe is way bigger than it should be. I think my current bot design is too wide. If I want to get it approximately the size of this, the entire width is 100 millimeters. So I want to make it 50, which means, oh, and yeah, let's do this. I'm going to, oi, no, not that. I want to select that. Oi, come on. Oh, it's because it's in the measure tool. There has been a change in Fusion recently that has been breaking me. It does not drop out of tools anymore like the way it used to. All right, I'm going to put, I want to snap that. What is going on with that selection? Okay, here we go. I'm going to start applying some constraints. I'm going to constrain that one. No, I'm going to constrain that one to be parallel to that. And I'm going to set a distance there to there of 50 millimeters, which it already was, but now it's actually a constraint. And I am going to check the length. How long should this bot be? Should be about, well, this one was 147 millimeters, about that. Let's make it 148. So we'll put another construction line across from there to there, and we'll also add a construction line there to there and lock it. So we'll lock that one. That's our axis reference. And then we're going to do a dimension from there to there and make it let's make it 148 millimeters. That is significantly smaller. Okay. So the layout of the bot, the way I had it, was quite a bit. 140. That's more like 144. Yeah, let's make that 144. Okay, so I need to bring it all in. Bring it in. Bring it in. Now, how am I going to do this without totally messing this up? All right, I'm just going to start bringing points in here. Where are the points on this curve? Bring it in there. Bring it in there. And bring this down. Yeah, okay, I'm going to... This is going to get really bad before it gets better. Really bad. Oh wait, no, I want to bring that to there. Snap that to that location. In fact, can I lock that to that location? Yes, that should be locked now. Okay, so now if I bring all of this down and this down, I should be able to get it. I kind of want a semi-straight area across the back as well, because I want to, let's bring that in. Why can't I get that off that constraint? Why is that snapped? Get off that line. Oh well, I can work with it. Take that up. Take that up. Yeah, something closer to that. But I think I actually need to bring this up a bit more, because I'm going to be having the motors turned around the opposite direction from the way the original was. For some reason, it is just not aesthetically pleasing. It is not. It is very distinctly not. Yeah, that's improving. I need a bit of a straight edge on the sides here, because the motors themselves have fairly straight edges. Just for a shock, let's get out of that and see what it looks like in a couple of dimensions. Yeah, wheels up there. It's not that bad. It's not really what I'm wanting, but we're getting there. All right, so now we'll pull in the components, which is going to make the whole thing shrink dramatically. There we go, and then we can move the wheel assemblies. Let's move this that way. How far did that move? -10. Let's take it -12. No. -12. Yeah. Maybe -13. Yeah. Okay. Moved at 13. And it needs to go back as well. But for now, I'm going to just move in that axis. I really should fix the rotation of the origin, so that I can move it in that plane without it without it screwing up the offset. Okay, so move. I want to move this one sort of there and there and how far is that moving? 25. Okay, let's get some zoom so that it decreases the movement. 10. I think it needs to be about 13 again, maybe 12. Yeah, I know. I'm very much just free-forming this when I should be being much more formal about it. How about we have the motors fairly close to the front, like that, with the wheels quite close to the front? No, I think it needs to be slightly further back. I am being so unscientific about this. This is vibes-based design. Come on. 10, no, let's try 7, no, 6, yeah, screw it, that'll do for now. We're just starting to get the vibe of the thing. And the other wheel, that one. A little bit more. How much is that? 12.25. Let's go 13. Yeah, it's further back than the other one. All right. Although I think it might be in a better position. I think that is slightly nicer. I'm going to redo all of this properly. Like, I'm going to reintroduce these motor components later.
G.
Fix your orientation and stop fighting it, says Tinker. Vic, enjoy your family event. Yeah. I think that wheel position, this one here, is actually pretty decent. I don't mind that at all. I think I'm going to bring it up this way by another millimeter. 13, let's make it 14. Oi! 1. There. 0.5. Yeah, that'll do. Okay. So the wheel that is on the right, I think, is where I want it to be. I think. Not that one, that one. So the axle is, yeah, so the wheel is back a little bit from the front, but not much. So one of the considerations here is if you're driving over obstacles, like say it comes up to the edge of a rug, you don't want the PCB protruding a long way past the wheel, because the wheel needs to be close enough to the front that it can grab onto the front surface or the edge of whatever it is and get up over it. But I think this position is fairly decent. That one. So, let's do the capture position, and then I'll say okay. I'm going to hide that. No, yeah, I'll hide that. I'll hide that. This one, I am going to. Can I do this within? I'm not even sure if I can. I don't know if I can do this. I've got an idea of what I want to do. I want to. No, I don't know if I can. Move type, pre-move, translate, rotate. No, can't do what I had in mind. Doesn't matter. Okay, so this section on the right is kind of it. Now, do I want to update the PCB design more? I may want to add, a little notch in the front. I'll definitely need to add holes for screwing things together, but that will come later. Use constraints, not random numbers. Yep. Oh, hey, John. Yes, I know. I am doing this in the least scientific way possible. I'm basically treating this like a lump of clay, and I'm just squishing stuff around at the moment to get a feel for whether I even like the idea.
At Tinker001 said, if you fixed your orientation and origin, you could copy, then rotate 180.
Yes, that is true. So, space for a battery, space for electronics. So what this means is the electronics will be sort of towards the front, I believe. I could put the H-bridges back here, behind each motor. So what I should do is update this by pulling in, here we go, there we go. So that's now pulled in the latest PCB outline. Something about that shape just doesn't feel right to me. Feels ugly. Feels like not a happy shape. I don't know why. So we need these straightish bits on the sides because we've got the motors to go there. We need
Balance it.
Balance it? We need a straightish bit on the front because that is where the ESP32 cam is going to go. The back can be curved. We're going to have a pocket in here. Let's see if I can do a selection. Yeah, so where it's highlighted approximately now, like that area, but not protruding back beyond it. In fact, I'll see if I can do it from here. Probably that orange area there, give or take, will be the space where the battery can go. And there can be like a 3D printed U-shaped surround that goes around it that the battery slides into. So that will be like a little captive compartment, and then there can be a strap or something across the back to hold the battery in. So you can pull the battery out the back if you want to.
Tinker001 said, if a special cam is being inset, don't need straight section for it.
Yes, that's true. You don't need a straight section for it. Don said, use a table tennis bat as your platform. Oh, I want to do that just for the comedy value of it. Yeah. If this was shrunk vertically, it would be like if you took that top part, if you basically just removed this chunk out of the middle, you've got the shape of a table tennis bat. And then the handle would stick down here, and you could put a little runner, like an idler, under the bottom of the handle. So yes, you could make one of these bots out of a table tennis bat. It's okay. I don't hate it. I think it'll do. All right. Right. I think it'll do. Yeah. I think it'll do. So, where were we? Back to the assembly. Okay. What I need to do is, thinking through the sequence here, defining the overall shape is a critical step. And that has to be kind of locked in and become the way that it is. So everything else, that is a fundamental constraint, and then everything else fits around it. So I need to decide, am I, oops, I'll close that one for now. Very cool work though, Austin. So, is this shape okay in terms of the overall outline? I think it is. We've got, it's 100 millimeters across from there to there. It's 148 millimeters long from there to there. I think it's all right. I'll pull in the other parts.
Why not a circle?
Oh, Crispin says, why not a circle? Yeah, you could do a circle like a vacuum cleaner. I think it complicates things a little. Because of the way we've got our drive wheels set up, yes, you could make it a circle, but the problem is that you need drive wheels in there somehow. So you'd need a slot inside the circle for the wheel to come down through. And I kind of prefer the idea of making it, for this application at least, I like the idea of making it so that it has a distinct direction. There is a front, there is a back, there are sides. Circle robots are cool for many things, but I think for this, we probably want to make it more directional. Thunking. Brain is working slowly. Rawhide. I am so much like Homer. Inside my head, I'm just going do. There is really nothing much going on. Okay, so finalize the outline. Okay, let's say it's finalized. We'll just say that this is the shape of the outline. So now what we can do is work with the constraints.
Balance it, have a skid at both ends, and allow it to settle on either end with 10 millimeters of fall, so it is still on only 3 points and doesn't get bogged.
I don't really like that idea because it'll end up rocking, which would cause potential problems for the vision system. So its field of view would change as it moves. And as you pick something up, the whole thing could rock backwards and forwards. You'd have a seesaw effect. Yeah, having front anti-tip wheels.
My eyeballs won't stop moving now.
Evil D says anyone worth their salt would make it turtle-shaped. Ooh, turtle-shaped. Let us see what specific shape is a turtle. Yeah. I literally searched for turtle shape. The difference though is the flippers versus the wheels. Yeah, because turtles have their flippers coming out fairly close to the front and and they're long, they wrap around. Whereas in our situation we have drive wheels that are on the side. It is turtle-ish shaped. Yeah. So one thing to keep in mind is that with the wheels, like if we come to a top view here, Oi, fit. See, these wheels are physically fairly large compared to the base.
Mount the wheels on the flippers. If you want a working shape, measure your head for shape, because that seems to work fine almost every time.
Measure my head. No, we do not want more of my head shape in the world. Okay, so balance point back there, battery in this area, so most of the mass is at the back. This axle is probably just slightly, I don't know. I was going to say it's slightly further back than I would like, but it's not bad, particularly with battery mass at the back. I just don't want it to tip forward when it's trying to pick something up. If you think about an arm being attached here. Ooh, I just thought of something. If from a geometry point of view, if the arm...
John's head with the wheels as ears.
Yeah, these are the wheels. If the base of the arm is attached at the midpoint on the axle line between the wheels, what that means is that when if the bot rotates equally around the wheels, so say you are rotating on the spot, it means that geometrically the end of the actuator is going to inscribe an arc, and the center of the radius of that arc will be the midpoint between the wheels. Now, this could be useful from an inverse kinematics point of view when it comes time to do the motion control, because what it means is that it makes it simpler to calculate the position of the actuator based on the known positions of the actuated joints, which means you can calculate, it's basic trigonometry to calculate the distance to the actuator from the origin point, and therefore if you are rotating, you are inscribing an arc of that radius. So that means, what does that mean? What it means is that my goal should be to mount the actuator at the center point of the axis, of the axles, which will be the point of rotation when the wheels are driven at equal speeds forwards and backwards. John says omnidirectional wheels, so then they don't have to be in line with the direction of travel. Yeah, well, that's actually exactly how the more expensive robot base works. So, where are we? I'm going to show you something. Where is it? Base. I can't remember what it's called. So 101. What is the base for this thing called? I have gone blank on it. My poor memory strikes again. Okay, so what I'm looking at here is we've got the SO101 arm. Where all of this came from is SO101 arms and wanting a low-cost equivalent. Define one less cosine call. So Evil D says 4 omni wheels on the flippers in an X pattern centered in the middle of the bot to make the kinematics easier. My face is hubcaps.
Jono's face is hubcaps.
Yeah. So SO101 robot base. What's it called? Where? What? Come on. Maybe if I go to the seed. Where's the seed page for it? Yeah, this one. Okay, so there will be a, you may also like to buy Come on. Where is it? Parts list. No. Related. Where is the base for this? The Kiwi. There we go. This is what I've been looking at. Yeah, so the whole point of this is a cheaper version of this. So this is a 3 omni wheel base. Where is our picture? Yeah, here we go. You can see it more clearly there. So this is 3 omni wheels, and of course you only need 3 omni wheels because you can drive them in any direction. And this can have the SO101 robot arm attached to it. So this is what Andy has. He has this base, the Kiwi, with an SO101 attached to it so that it can drive around, it can pick things up. But the reality is, so this says USD 179. That is not telling the whole truth. Not in the slightest. Where are we? Kit, mobile base. The reality is that by the time you have this base plus the SO101 and the Raspberry Pi that you need to run it and all of the other add-ons, you're looking at $1,000+ robot. Like, I'm talking in Australian dollars now. So this is 179 US for like the basic parts for the kit for this base. And then you add the arm onto it and the Raspberry Pi and add a camera and all of the other stuff. Yeah, it is $1,000+ to put one of these robots together. So the whole idea with this is that it is a lower cost entry point equivalent. So what we want is something that is functionally very similar to that Kiwi base, which is the 3-wheel omni-wheel system, and the SO101 arm as the actuator that goes onto it, but we want to make it a super low-cost version just to get people started. And they may then want to go for the omni-wheel thing. But the whole idea with this is this should be like a $100 robot. It's not a $1,000 robot. Which is why we're using $5 DC motors and things instead of $50 or $100 omni-wheel assemblies. Okay, so yeah, this is like a little pocket-sized, super cheap budget version of that. Okay, so where this leaves us is shape of the PCB, 2 drive wheels sandwiched between a lower PCB and an upper laser cut plate. What this will mean, this is completing a thought from like an hour ago. The whole point of this, where I'm going with this, is that we are going to end up with a robot where all of the fixed functionality is attached to the lower plate, to the PCB. That means that the entire top deck up here is flat and clear for us to add whatever we like. This is the expansion platform, the expansion plate. There are going to be a couple of screw heads that come through this because inside here there will be a 3D printed bracket that these 2 plates screw onto. So the PCB is going to screw up into the bracket, the top plate will screw down into the bracket, and the wheels will be attached in the same fashion onto that same bracket. So there will be some bolt heads exposed on this top plate. There will be a couple of bolt heads exposed up here around the motors, and there will be a couple of bolt heads down the back because we're going to need to screw the back down onto the little mechanism that encapsulates the battery. But for the most part, this top deck, that bit highlighted in blue now, is going to be clear. So we can put our Lego base plate on here, we can glue it on or laser cut holes into this, or do whatever is appropriate. So this whole top deck becomes a platform for expansion to add the arm onto, or whatever else you want to do. So, or you could put a LiDAR on there, or other cameras for doing surveying around the home, or whatever. This is where my thought process is going. Paul says if you have grabbed something, you can turn the base without having to adjust the arm. Yeah, that's right. So what you can do is you can grab something, rotate, and put it down, and you know that it is going to be on a circle where the radius from the center point, the starting point, is the same. So you could pick something up, rotate 90 degrees and put it down, and you would know geometrically where that actual point is. Yeah. So this stream, I haven't really done anything, but I think I have clarified my thoughts. And I was kind of in a bit of a decision paralysis situation leading into this stream, because there was the whole thing about, do we want to do underslung or overslung? And I think a sandwich approach is the right way to do it. It could be done with 2 PCBs as well. So this top one could be a separate PCB. But PCBs aren't that cheap in large volumes. Let's just see if I can get a quote on. I'm not sure if I can even do this through JLC anymore. Let's see if I can manually put dimensions in. Let's see. So if I want to, oh yeah, maybe I can. Get out of the way. So it's going to be 100 wide by 148 long. 148. Give me a price. Give me a price. That's a lie. There's no way it'd be that cheap. Okay, so 100 by 148. This is based on some ridiculous discount thingamajigamy. Let's say I wanted to make 50 of them, like a reasonable number. Okay, let's see what it calculates out to. Dad, how is that so cheap? What is going on here? Why is this only $71 for 50 of those boards? I don't get it. I'd want a stencil, of course, and we might want something other than green. If we want to, let's just pick blue. Okay, so $71. Let's make it blue. Still $71. So there's $100 of shipping as well. Black, does it change the price? Still $71. I thought it would add a surface finish fee. What if I go red? I'm trying to find the expensive stuff now. This feels like a bait and switch. It feels like if I actually uploaded Gerbers, all of a sudden it wouldn't be $71. It'd be $150 or something. Purple, even purple. I think purple and yellow are the colors that typically cost more. Oh yeah, $95 it's just gone to on yellow. Yeah, and 2 more days it takes, and 2 more days on purple. Yeah. Yeah, yellow is a horrible color to try to paint anything with, because it has very, very poor opacity. If you want to paint something yellow, you pretty much have to paint it white first and then paint yellow over the white, because it is almost impossible to make yellow paint with high opacity just because of the way the pigments work. You need the titanium in it. So, the titanium powder.
Is it cheap because you haven't got the circuits written on the board yet?
I don't think so. Yeah. Anyway,
At
the
Tinker
point.
001 said, throw together a simple board using your outline upload Gerbers.
Yeah, that's what I could do. I could just export the Gerbers from this now, but I won't. I won't right now anyway. I'm actually meant to be somewhere by 1 o'clock, helping my sister. That's the wrong way of putting it, because that is making it sound like it is something that is her responsibility when it's just as much mine. No, the point is that I need to be somewhere at 1 o'clock with my sister because we are doing something that is important. So I do need to end the stream soon, very soon. Okay, so the reason I was looking at this is I was looking at what it would cost. Let's just go for basics. And say we are doing 50 PCBs. It's going to be $180. So it's like just under $4 per PCB. What I was thinking was, what if the top was also a PCB? It could be a different design. So I'm saying don't use the same design for both of them, but I could design 2 different PCBs, one for the bottom, one for the top. And the top one could do things like include a connector for the power and comms that goes to whatever device is attached to it. Because the actuator that mounts up on here, or a LiDAR unit, or cameras, or whatever else it happens to be, is going to need to communicate somehow with the microcontroller that is on the bottom board. So one way to do that would be to make this top piece also a PCB, not laser cut acrylic, and to have comms that passes through between them. We could have connectors, or we could have a little connector in it, like a cable that plugs between the two of them, to pass signals up to the top piece so that we can then, we could then have those signals exposed up here. And I guess you could do it either way. If there is some kind of an expansion connector on the bottom PCB, the top piece could be either another PCB with a matching connector, so your cable between them, or it could be a piece of laser cut or acrylic or 3D printed, and then the cable from that expansion just goes up to whatever device it is that you've got on the top. So either of those would work. So I'm not necessarily painting myself into a corner, but what I need to do is design it so that the PCB that's on the bottom will have all of the necessary expansion signals exposed on a connector that is possible to get to, like towards an edge, like on this back left corner, for example, just around this area. Yes. Austin would add RGBW LEDs to the top board. Yes, Austin would. And Austin would not be wrong to do so. All right. I am going to have to
The top
call
board
it.
reverses the function, utilizes a sensor to know which way up it is, and then switches accordingly to take over control when the bot flips over.
That never even occurred to me. It could be symmetrical. Put it down that way. Put it down that way. It's the exact same thing. Just have an accelerometer in there. Yeah, so if the whole bot flips upside down, it doesn't matter. You can just put it down either way and it works just fine. We just need to make sure that the camera is vertically centered between those two, so it is symmetrical when it's inverted. Strange thoughts, Crispian. Strange thoughts. Okay, I'm going to hit save on all of these. And come on. Oh, it's got that annoying thing going on. Yeah. Fusion has got into a state where you can't save that particular thing for no reason that it explains to you. So in here, if I want to save it, I want to save it. Can't. Saving 0 of 1 designs. Out of date. Okay. What happens if I pull it? Unsaved changes. Do you want to discard? Yes, I want to discard and update. Okay.
Send it to space, confuse the heck out of it.
Which way is up? Get rid of that. Get rid of that. Do I want to save? Yes. Yes. Okay, I think I've got there. I closed everything and I saved it. Am I thinking inside the box or outside? Does it come on a box? I don't know. All right, I'm going to have to go because I have to go and do important family things. Not fun family things, just important family things. In fact, they are family things that I would really, really, really rather we did not have to do. But there are certain times in your life when you have to do things that you don't want to do. But you've got to do them anyway. That's reality. That is being responsible. So I'm going to pretend to be responsible and I'm going to go and do stuff. I need more of that coffee. I definitely need more of that coffee. Okay. I think I have a plan now. And it's a plan that I'm more settled on. I've been feeling unsettled about this whole thing, the whole question of motors above, motors below. And now the answer is, why not both? Motors in the middle, plate bottom, plate top, gives us best of both worlds. So let's do that. Henrik! Henrik! Here it comes. Is it going to? I don't want to end the stream before this thing has come through. There it is. Thanks, Henrik. Okay. Thanks for the banana, Henrik. I'll get myself a dose of potassium and fuel up for what I have to go and do now, which is probably going to be involving ripping up the grossest carpet that you have ever seen. But it has to be done. So, as Gavin says, ta-ta for now, and I will see you all next week, if not before. Some of you, hopefully, I will see before. Okay. Thanks. See ya.